Just a very quick look at the agenda. We want to have now really a look into the infrastructure, how this looks like. Then we will go into a couple of other examples, how this can be used. And then I will go back to this associated partner program and the implementation challenge, because this is, I hope, for you something which is a good way to become more some kind of driving force, and deciding on where all these things are going to, and in that way give you a chance to really decide on our ways to do things. Just as a reminder, the slide Tim presented last time, we have this infrastructure which can then be deployed inside your organization. We have the reference infrastructure to show that, or to have this easy access. But in principle, when you really want to run into something or run something for your own work, which is perhaps also dealing with confidential data, then it's clear that this should be inside. But that is what Tim also will present. That this is a little bit of work, but we will make it as simple as possible and also give you support when you are interested in deploying. The other thing is that these are then the services, which are then really the risk assessment services, the predictive toxicology services on top of that, which we will then present in a second demo. That was already my introduction, and then if you could just make a Tim presenter, then he would go into the infrastructure.
So I'm just gonna. We have been building QSAR models and publishing them, and I'm gonna give just a quick background to the QSAR stuff, and then I'm gonna do a little bit. When we're doing QSAR modeling, we build regression and classification models to try to predict outcome of logical systems. And traditionally, it's been a massive task of picking relevant descriptors, machine learning models, and so on. But it's turned out that either support vector machines or random forest, together with some that often performs quite well. So we thought, let's standardize this. And we use support vector machines together with a so-called molecular signatures descriptor. The one problem with QSAR is the question of whether you can trust the prediction. Since when we're testing a molecule, it's almost by definition it hasn't been in the test set that made the original estimation of how good the model is. So you can always think maybe this molecule is so different that the model really cannot predict it at all. We're talking about applicability domains, and to say that this molecule might be in the applicability domain for the model or not. But it would be nice to instead say that we have a confidence interval for the prediction. And if the model actually is sure about the molecule, then it will give a narrow interval, and if it's unsure, there's something really weird, it will give a less narrow interval or a wide interval. So we are using conformal prediction implemented in CPSign to build QSAR models with confidence. And that was the very short background. Now I'm going to demo this. It looks a bit like this. Let's see if I can get this up and running. So this is a service running on OpenriskNet for the moment. And if I draw a molecule, it will start predicting the molecule. And you see here that we get a prediction interval for this one. So if I give it a low confidence, I get a kind of narrow interval. And if I give a very high confidence, I get a very wide interval. So this is just a model that predicts log D. Now, as I said, this is a microservice. So of course we have this Swagger endpoint that's running the model. So we have one endpoint for prediction and one that generates the image. So this is all Swagger, and there is a API and a REST-based system. I also want to quickly show you some other models that we have been deploying. The first one is one called metpred, and since I'm not a chemist, I'm actually gonna just copy this smile string here. Oops. So that we get something that is meaningful. So this one is cytometabolism and reaction type prediction service. So we get a list of reactions that can happen for this molecule. So this is not the QSAR model. This is more of a lookup in a database that's behind this. And then we have the predicted target profile. So in this case, we don't have one QSAR model, but we have an entire, what do you call it, set of QSAR models. So when we make a prediction for this one, we get, for each one of them, we get a p-value for how likely it is that it's a binding or not binding for each of these different targets. But this is also made with these microservices. So each one of these little model is a microservice, and we can go and have a look at the image, just like I said, the CPlogD one. Why didn't that work? This was working a week ago. Maybe I'll take another one. This should run because it's well. There are some. The machines are a bit slow, and sometimes it takes a long time. We don't really have dedicated services, and sometimes there are other things running on the same server and stuff. Never mind. The idea was that it would pop up an image just like this one for each of these models. So this is one way of interacting with these models, but of course you can also use the Swagger and code towards them. But the main idea here is the confidence thing, that if I change the confidence, I get less secure, and if I do a low, then they will start saying, it's either one of these two, it's either binding or not binding, and we can't really say for sure, but it depends on what confidence you give. Yeah, that was pretty much it, because that stuff does not work. Once again, it's a bit of development. So we are building a web-based application for building these sort of QSAR models, deploying them. You sort of upload your data set and you build them, and you get this. You deploy a microservice and you get the REST API, and you get the Swagger definition, and you can you get this confidence interval and all of that stuff. But as I said, for the moment, the servers are a bit not up and running perfectly, and I haven't really set it up all up, so I'm not going to demo that now. I'm going to move on to someone else instead.
Okay, thank you very much. Questions to that?
Hey, Thomas, this is Fred Classic.
Yeah.
I understand that you weren't able to show the full capacity, but what I've noticed in looking over QSARs for the Nano Informatics roadmap is that people talk molecules, and you show organic molecules, but many of the materials of current interest are not molecules. They're ions when they're dissolved in water. So silica, calcium phosphate. So do you have models, or are you working on ions separate from molecules, covalent bonded molecules, and those materials that are ions in water? So I raised the issue, just wondering if anyone has, if Jonathan is working in that area, Thomas, or is there someone else who's doing that?
We personally not, yeah, and or Douglas Connect, and it's Jonathan, if you have something, please jump in. We have another partner from the University of Mainz who is also more in the nano area, and the nano LASAR, perhaps you heard that, is also integrated. Dennis is here, but perhaps. It also, one of the important things is always that we provide something, and since we are, myself as well, are coming from this molecular area, we perhaps also decided on showing that more. Yeah, but in principle, when you, I hope with the other, what we will show now, with how we propose to interlink these services, yeah, and then with the integration challenge, we also want to bring in other people's tools, and if there is somebody really in that, which is then concentrating on ions or even nanoparticle. That you have a nanoparticle dependent QSAR modeling, which then has other descriptors as small molecule descriptors, but in principle the idea is the same. If we get something in and we would like to cooperate with partners there, and bring in this way this information in, and I hope that, or let's move on to perhaps to the workflow tools, because then this concept that in principle it's a platform where services are deployed, not only by us, but by many people. Then this also opens up a lot of more possibilities. And as I said, we also are interested in this kind of nano-specific case studies, and then we would bring in these nano-specific tools.
Thank you.
What I would like to start, or what we are going now into, is this really that we want to combine. It's not that we provide specific services, we want to combine them and in that way make them more active or more usable and expand their usage by being able to extend or to combine them in the best way. The first thing, again, this is our reference site. What I will do now, because I'm not logged in at the moment, I will just click on this Jupyter, then I have to sign in. And as we said, this can be done by LinkedIn accounts. Tim will probably show something else. Okay, I'm now logged in. That was everything, because I was already logged in LinkedIn. It was possible that without any new password, I just was logged in, and then I can start this Jupyter notebook. And Jupyter notebooks are, in my opinion, really a nice feature because they give you. Okay, that was clear. Try it again. Here we go. Good. Okay. After a little bit of clicking, you can script here many things. You can go in, and what I want to show with this example is how you can now go in and combine these different services. At the moment, we are also integrating external services, because we don't have everything in OpenriskNet, but the goal is to get more and more really inside, because then there is really no transfer of information outside of your own domain necessary. If you're including some external web services, sure, at that point of time your data is going out, but everything which is in OpenriskNet you can just bring in and then use it internally. What I show here, and I think this is something, even if I use at the moment also small molecules, but that is something which is also very easily usable for nanomaterials, is pathway identification, or it's going from omics data to genes, overexpressed genes, and in that way, and then look up which pathways are these important or are somehow correlated to these genes. Everything is going while these kind of API calls. I always query with the known systems. I query different services, and they are all based on these API calls. The first thing is that I go in here, I define a couple of molecules, and I want to see how they look like. I just give the names, and then I query one of our services, which converts these names into some kind of chemical usable structures and SMILE strings, and then you can just show that, and you get the SMILEs back. With a little bit of manipulation, you also get nice pictures. That was the first step. Now we have something we can use here, because we have a chemical structure, not only names anymore. Or we could now start calculating properties for these in the same way as, for example, for nano, you could go now in checking properties of these things, and from databases or from trying to calculate molecular descriptor or nanoparticle The idea is hopefully the same. We then look into an omics database, the TG Gates from Japan. We really have a nice couple of larger set of omics data, harmonized omics data sets. We can put in different filters. What we exactly want to know. Yeah, we have only in vitro, human liver, in vitro samples, single exposure, 24 hours, and the highest dose which was measured. If we then run this out, we get this JSON format, which is a little bit complicated to read for a human being, and it's not meant to be read by a human being. But again, with a little bit of manipulation, you can get that into these nice tables, which are then much easier. But by selecting now the probes, you can also, for example, find out which of these probe sets are really overexpressed. What I took here, I think, larger than, or one, yeah, they are a little bit overexpressed, but you see also here that we have fold changes of 5 and so on. Yeah. Since this is all Python, you can then start and use whatever Python library you want, for example, to show heat maps, and going then with these data into the next service, which is BridgeDb, which is a service from the University of Maastricht, which converts the TG Gates identifiers, which are here, into something which is more better known. This is, for example, here the ensemble identifiers or the HGNC identifiers, and then you get here your columns with these identifiers, which then help you to go into the next service to ask for pathways. And here we use the WikiPathway service, which is an external service. Even if we have plans to bring that in, but at the moment it is an external service, and this external service will then give for the genes which we specified, which we identified as overexpressed, will go in and download all the different pathways which are associated with this gene. When you're a bioinformatician, you would say, yes, sure, what are you doing? This is playing around, but that is also not what I wanted to show. Yeah, it's not the perfect, it's something very cheap, and you probably would need to go much more in detail to now understand which the pathways are really relevant. What I want to present here is really this way to combine these services into workflows, making them easy accessible, all these different tools, and in that way bringing it or speed up this development of these workflows. And Jupyter and Python are definitely are something where you need some kind of programming experience mainly for developing also these workflows. And with that, I can directly link over to Tim, because he will then present something where it's not so much, where it's not important anymore that you really have programming skills. It is a tool which does similar things, but in a much easier way, and in that way also open up then perhaps also predefined workflows to users which have not so much computer experience. No questions? Then, Tim, just please go ahead.
Okay. As Thomas said, we've got a number of applications that have already been deployed into the infrastructure, and we'll come back to looking at the infrastructure in a minute. Some of those applications are just pure services. They have no interface at all. They're just there to be used by other applications. Some, like the modeling web that Jonathan demonstrated earlier, have user interfaces, and you can use that application within that user interface, and that might be enough for you to do your work. But very often, in order to solve more complex problems, you're going to have to use multiple tools. And that's where workflow tools come in. Thomas showed you Jupyter notebooks, which are a really nice way of tying things together and providing a record of what you've done. They're typically used with Python, but you can use other languages as well. And they're really great tools, but they have the fundamental limitation that you've got to be a programmer in order to use them. And if you're not a Python programmer or not a programmer of any sort, then Jupyter notebooks won't be accessible to you. And that's where the application that I'm showing you here comes into play. This is the Squonk Computational notebook. So it's a notebook like Jupyter in some ways, but it's designed purely for end users. You use it by sort of dragging and dropping and pointing and clicking and things like that. You don't have to write any program code at all. You do have the option in cases of doing that if you want, but you can do the vast majority of things just with a visual paradigm like this. So what you're seeing on the screen is a list of the notebooks that you've created. In this case, I've just got 3 of them. On the right-hand side is the canvas where the workflow has been assembled and executed. And in the bottom left corner are the components, or as we call them, cells, that can be added onto a notebook. And we'll see various aspects of this over the next few minutes. So firstly, what we're looking at here is a very simple workflow that just investigates some solubility type, partitioning and solubility characteristics of molecules. And don't worry too much. This is just related to molecules, and this is just related to partitioning and solubility. What I'm trying to illustrate here is that the first step in the workflow is to upload some, in this case, some structures into the system. So we've got an upload of an SD file to load the structures into the system, and then the paradigm here is each of these cells has inputs and outputs, and when you execute them, they do something to the inputs and convert and make that available in the outputs, and then the outputs can then be the inputs to the next step. Fairly straightforward, fairly common as visual programming type paradigm here. So we first upload some structures, then we calculate log P with a couple of services, one using OpenChemLib, one one using RDKit, and then we calculate solubility again with OpenChemLib. Now these services are built into Squonk, but we could in principle be accessing services from the other partner applications that are on the that have been deployed into the environment. And that's where the service integration and the service registry that I briefly mentioned last time come in. So we'd be able to discover services from other applications and then incorporate them into these and make them accessible. So basically, in this case, we've executed 3 services, and then we can visually look at the results and then filter the results and do what we want with them. We could look at the outputs of these, so you see structures and the properties that have been calculated and things like that. So there's a sort of a simple example of how we can execute services in a simple workflow. Another example here would be a data curation workflow, where we're pulling in some assay data from the Chembl database. We've got 4 different assays, which are cytochrome P450 inhibition assays with different P450 isozymes, and each of these executes a request to Chembl to retrieve the data, and that retrieves us 4 different data sets. But we don't want 4 different data sets; we want one single data set. So we then pipe that into a tool where we merge the data sets based on the Chembl identifier and a few parameters about how to handle duplicates and things like that. And then the next step in the workflow is to clean up the data. So whenever you've got some data, the first thing you nearly always need to do is clean it up in some way and transform it. The transform of the data, so the text becomes numbers, and you convert the numbers into PIC50s, and you delete the data you don't want, and things like that. So this is basically a data cleanup step, and then the next, the output of that you pipe into another property predictor. In this case, it's a Lipinski filter that's executed. So we're filtering out non-drug-like molecules, and then you can visualize the results and filter them. Basically, you can say, okay, I only want things within a particular log P range and things like that. So each of these executions is going on through a service that is accessed, that is running in the back-end infrastructure of the virtual research environment that we have deployed, and this obviously is the reference site that we're using here. So that's the sort of things you can do. Very quickly, I'll just give you an idea of how you do that, because it may all seem a bit too magical at the moment. So what I'm going to do here is I've got a very simple workflow that I'm going to illustrate clustering of chemical compounds and prediction of activities. So I've already uploaded a data file just to keep things simple. I now access the services that are available. I want to do some clustering, so I drop that onto the canvas. I then wire the two together. I maybe specify a different threshold, maybe different parameters. I execute it. And now what's going on here is the output of this cell, which are the structures, is now being sent to a service that does the clustering. And when that's completed, we will have clustered molecules. And then let's say we want to do a Lipinski filter on those results, so we put that onto it. We're just getting ready here while this is executing. And okay, that's now completed. We've got 27 clusters have been identified. We can go and look at those if we wanted, but actually what we'll do first is we'll calculate we'll apply the Lipinski filters, which means calculating these different properties and applying the filter. You'll see we've now filtered down from 756 to 717 results, and now we can view that and decide where to go with that data. So some very simple examples here, but the key concepts to get across is that you can visually design a workflow, and each step in that workflow can be accessing some of the back-end services that are available from not only within the Squonk notebook itself, but also potentially from other partners. So we could, for instance, in time be accessing some of the predictive models that Jonathan was showing earlier. So that's, I think, enough for this. Any questions on that?
Fred has a question. Fred?
You mentioned Lipinski, that's water solubility. I'm interested in particles. A particle essentially is low solubility, otherwise it wouldn't be a particle. And I'm interested in particle solubility when the pH changes between water and, let's say, a lysosome. Is the Lipinski model able to be extended to low pH, late endosome, lysosome type of conditions, or is it only for physiological pH around 7.4?
Well, the Lipinski filter is really a drug-like filter. It's not really, it doesn't cover solubility, but we do have solubility predictors as well. Some of those were shown on the first workflow. The ones that I'm aware of are classic sort of drug solubility, organic molecule solubility. But basically, the answer to your question is if there is a service or piece of software that can do that solubility prediction, then we can integrate that into the infrastructure and make it available. We as the partners may not have all of those tools, but this is why we've got the associated partner program and the implementation challenge, where we're trying to extend the range of tools and services that we have available. So if those services are available, then we can probably deploy them into the infrastructure and then make them accessible.
Thank you.
And perhaps I can jump in, and Isolde could also help me. My big hope is also that we get with Nano Commons and then additional or associated partners like ACE Nano, which are really measuring this FISCAM properties. I hope that we get the data to then do these model developments. And what Jonathan perhaps not or raised or said a little bit, yeah, that this whole these models, we have the infrastructure to build these models, and then the question is where do the data coming from? And as I said, I think we have these projects like ACE Nano, which are really concentrating on this FISCAM properties at the moment, and producing data, and in that way giving the chance to build these models, which can then also probably, and this is what I don't know, perhaps you can help me with that, probably also get this pH dependence in there.
Yes, absolutely. So we are currently trying to incorporate all of the data from a former project that's ended, NanoMile, and a running project, NanoPhase, which have a lot of this sort of data. And working on, there is lots of data out there. It's just getting it into the accessible form. And then, yeah, for sure, we have also information on pH and dissolution. So there are data sets that are just not yet accessible.
Many of the nanomedicines that are going through the FDA are going to be low Lipinski values. So when I see the Lipinski and filter, it may be dropping out the items that are of most interest to formulations that would be called nanomedicines, and that's the direction I'm going in. It's not the measure the dissolution, it's what do you do when it's low dissolution, but you still want to do something with it in a physiological sense. But thank you very much.
Good.
Okay, so let's move back to where I tried to start off, and that is a little bit more about the infrastructure itself. And I'll try to be very quick because I know we need to cover the Associated Partner Program. So I described last time how you could deploy your virtual research environment to your own infrastructure. This is our reference site that we've deployed onto the Swedish Science Cloud, but it could be your virtual research environment, and you could have deployed it into your own hardware or onto a cloud provider like Amazon. And what this is basically a complete environment for managing and operating the tools and services that you want to deploy. Here's a dashboard. It's a self-service type system, so you can just choose what to deploy into it. All of these things are sort of infrastructure components, but you can imagine we've got tabs here that deploy toxicology applications and databases, chemical databases and nano databases and things like that. And what you can do is, if you've got the right privileges here, you can come in and create a new project, which gives you a sort of isolated namespace where you can start to operate. And then you can just come along and say, right, I want to deploy an application, and I'll deploy, in this case, this application. And this could be any of the applications that we've seen so far. There are other ways of deploying them. You don't have to go through this mechanism, but you specify where you want the application to go, a few parameters, and then you say create. And now this application is being deployed into the infrastructure. And we'll see here, this is the application that is getting deployed. This will take a few minutes, so what I'll do now is quickly show you what this would look like once it's happened. I'll do that by showing you a couple of the projects. This is one of the infrastructure projects where we run databases and message queues and the single sign-on system. What you see here is what are termed pods, which is basically where the containerized applications are running, and you'll see that it's monitoring how much memory and how much CPU usage and how much network usage all of these things are using, and you can easily go in and say, okay, my application is getting overloaded, and sorry, I didn't want to do that one. I wanted to go back here. My application is getting a lot of usage and it's getting overloaded, so I'll just scale it up. And now I've scaled it up to 3 pods. And so 3 of these applications are running, and they're being load balanced across those 3. So I won't go into this in any more detail because I know we're running out of time. But this is basically what you get when you deployed your virtual research environment into your infrastructure. It provides a very nice and simple way for you to manage and monitor the applications, and you can go in there, and it's then your environment, you own it, you control it, you can deploy what you want to it and use it in the way you want.
When you are interested in really deploying that, what I can say is, on the one side we have also recorded, and we will make it available, a much longer description of this infrastructure, how it looks like, how you work on that from one of the previous meetings. The other thing is that we would be really happy to help you and support you when you're really going this step and saying, yes, I would like to have that in-house. The earlier you come, the more time we have to help you, because we hope that this kicks in at one point of time, and many people doing that, but especially the first people, where also our description is perhaps not perfect yet. We will definitely support them with all the means we can. If you give me a couple of more minutes and make me presenter again, I would just run you through our associate partner program, which is in principle what I just said. Is it's meant to support third parties, you as a user, you as perhaps somebody who wants to deploy services, help us to develop, again, the non-specific case studies, bring us in. We have different ways to communicate with us. The first one, you are here, you are in our webinars. We are at different conferences if you want to talk to us in person. Unfortunately, there is now this overlap with the US meeting, where unfortunately not too many people of us can join, but Isolde, I think, is there, therefore you can also then contact her. We already had this requirement survey, and we have a help desk whenever you run into problems. We have this reference infrastructure for the first trying it out, and then we have started to really document how you can put that onto different computer systems, from your laptop to the high performance computing. This has to be optimized definitely, but I think with our help, our personal help, it will be possible to employ, or if you have a little bit of background in computer, then we should be able to get that running for you. This is just, I think it's a little bit, we are already a little bit further, but these are the meetings we will come. And there is also the US Nano meeting in there. The survey, you can look at that just very quickly. I hope it's not so much work, but you see here also that it's very general questions, but then we are also included some very, very specific OpenriskNet questions, because now we are at a stage where these questions will help us to make it better, and see if that is working for you, and what we should invest more time in. The implementation challenge I mentioned already. The goal is really to get third parties, you as a developer on there, getting you involved, and making your tool also more accessible to others. And in that way, brings it to a larger audience, and improve increase the dissemination of that in a way that you can really, you can profit from that. If you're a service provider, we want to make that you profit from that. And we also provide a little bit of money. I think this is also possible in the US, that we also ship that to the US. These are the steps which are needed. There are 8 what we put together. The first one probably you have already some of them, like an API. That would be great. If not, we can support you. And then there are some OpenriskNet specific things. And then there is a lot of things which we have to do anyway, or which we do for you. It's listing in the OpenriskNet discovery service. That's the first thing, to bring it inside or make it known for inside OpenriskNet. But then we will also go out and make it available and seen in much larger tools like the bio tools. These are more European things, but I'm pretty sure there are also American versions of that, which we can then also include and send out this service automatically, that these will be indexed in these different services. Yeah. Okay, I will jump over that. This is just a little bit of the API design concept. Final words to the implementation challenge. We had the first deadline at September 30th. This is over, but that doesn't matter. Just apply. We will extend that until the 31st of October. Therefore, it's not too late to apply. We have some criteria because we would like to make or increase the applicability of this of OpenriskNet as much as possible. Therefore, we would like to include many other tools which are complementary to what we already have. But you saw that the Nano side is still very much underrepresented. Therefore, the chance that you get some Nano tools in there is very, very high. If you are not a service provider or a software developer, we have also this associated partner program for both for service providers as well as early adopters, which gives you additional support from our side. You can really directly come into our design meetings where we structure what has to be done in the next future, how do we improve on that, and being a part in there, in this a full, more or less a full partner in the project. We want to make it easy for you to start. Therefore, this is something which you can think about, and perhaps you want to join. It's not necessary. Yeah, the platform is open to everyone. Giving feedback, or also coming in there and working with us on the case studies, even proposing new case studies. That is all possible without being an associated partner. Associated partner is really then if you really think this is something very nice and you want to become more involved and even more deeply in the technical details and technical implementations and the scientific guidance of where this goes, then there might be a reason to become an associated partner. But as I said, it's not really necessary. We want to make it as simple for everyone to contribute as possible. These are the partners we have already. That was all. I hope we gave you a good overview of what we do, and I hope that you try it out. I hope that we get feedback from you on what you would like to see and how we can provide you with even better tools and better services. And this is the end from our presentation. I think we are already over time. But if we give you a little bit or a couple of minutes, then I definitely would like to answer every question you have.
Thank you so much.